All right, I talked way too long about stuff that doesn't matter. Here's what matters: composition of functions. So composition of functions, we have lots of different ways to write as mathematicians and lots of different ways to say. So one notation you'll see is this like fog notation. This we read as f composed with g. Oh my God, I can't write. Composed with g at x. Great. Um, And that to me doesn't mean a lot, to students at least. F composed with G at X. The way that this makes a heck of a lot more sense is when we rewrite this notation like this. And these are equivalent. And this basically says, in my mind, how I like to read it, F of, oops, doing too many things in my brain at once, of G of X, right? So we've got all these things sort of inside of each other. Now, this is very different. This is not the same as our multiplication. This is not f times g of x. This is something different entirely. In fact, we know order of operations wise, we always deal with the most inside parentheses. So we're going to deal with the g of x, and then we'll move out to the f of the g of the x. So this makes sense with an example. Let us go ahead and do an example with numbers so we can really see how this works in steps. All right, and then of course, to make things fun, let's go ahead and do this with all the different ways that we might see our functions. So let's start with a table, our numeric versions. So here's a question I found online. Don't know where from. If we want to compose, we can see here we've got our little fog notations. Let's look at A. First question says, let's find f of g of 1. I'm going to go ahead and rewrite that in the other notation because that's just how my brain likes this. So the first thing we're going to do is we're going to deal with the most inside piece, which is g of 1. And we know that just means what is g when x is 1, right? The output. So we know where x is 1, and we're going to look and see, okay, at that point, g is equal to 0. So now we can go ahead and replace that in this notation. We say f of, and instead of g of 1, we know g of 1 is 0. And now we have a whole other thing that we can go ahead and evaluate. We have an input of 0, and the output for f at 0 is 5. So that is how we can do this using a table. So feel free to try out, I guess we can do B on your own. All right, so looking at B, I'll go ahead and just do it right here next to it. This is f of g of 2. So in this case, we're going to figure out what g of 2 is. So that's f of negative 3. And f of negative 3 is equal to 11. So you should have gotten out 11. And it doesn't have to happen in this order. You can see in C and D, we go ahead and reverse this. And the order matters because C is actually the exact same question, right? Not really, but it looks the same. And this is where we learned that this composition is not commutative, right? It doesn't go both directions because in this one, we're doing G of F of 2. So now we're going, okay, well, F of 2 is 1. This is G of 1. And G of 1 is, oh, that whole thing is just 0. So very different, 0 versus 11. And we can compose a function with itself. If you look at E, right? E is G of 1. Again, we can take a moment to replace G of 1. We know it's 0 because we found it earlier. And G of 0 is back to 1. All right. So that is composition of functions from a table. We can, of course, what's another way that we can look at stuff? We have the algebra. So we can just make up two functions. Let's go ahead and say f of x is equal to, I don't know, 3x minus 2. And g of x, let's just go ahead and have it be x squared. So we can do any of those problems we just did. Let's redo f fog, our f composed with g at, let's do at 1. And we know this is f of g of 1. And if we move from the inside out, g of 1, well, that's just going to be 1 squared. So we have f of 1. I'll use my yellow. And then we're plugging 1 into the second function. So we're going over here with that 1. So 3 times 1 minus 2, which is equal to 1 again. This is what happens when you make up your own problems. You get a bunch of 1s. But let's go ahead and do g of f of 2. So let's reverse the order. G of f of 2. So I like to rewrite it. Take your time. Pause the video. Try this one. First step is to figure out what f of 2 is. If I plug 2 into that f function, looks like I'm going to get 6 minus 2, so I'll get 4. And then if I plug 4 into the g function, I'm going to get 16. 4 squared. So that's how to do it algebraically. Now with the graph, it's again adding a layer of complexity. So let's go ahead and just do one more with the graph. And here's where I have to be careful, because if I choose something that's not on the actual graph, I'll get myself in trouble. So let's do Goff g composed of f at, let's do -2. And then let's also look for, as our second example, f composed of g at, let's do, trying to figure out what's not going to hurt us with looking for stuff. Let's do -5. All right, so if we take time to write these out in the other format, again, we just have to use the skills that we got out of the function party Desmos that we did. So f of -2, that's our first thing. So this is saying x is equal to -2. What the heck is my y, right? What's the output? And we care about the f function right now, so we're only looking at this function. And then we're trying to figure out where does that thing, how tall is that function? What's the y when I'm at -2? So we can see x is -2 is here, and the corresponding y is 0. This point is -2, 0, which means f of -2 is 0. So we're looking now for g of 0 after we replace that. And it's the same business. Now we say x is equal to 0. What the heck is our y? Except for we're on the g graph now. So x is 0 is when we haven't gone left to right, we're here. And on our graph, we're here. So we're at 0, -4. So the output of our graph is -4. So that is our f composed of g. So we just have to go through finding each of those pieces by hand. If we need to, we can always sort of make ourselves a table, right, if that makes you happier. Right, in this case, we had, f of x. The first question said, okay, we have -2. What the heck is my f at? Okay, that's at 0. And then we had a 0. What the heck is my, we could fill out the whole thing by looking at these and just taking ordered pairs. Here's 0, 2. -1 is at 1. We could make the whole little graph and table for f. Get out of here. I don't want you. And then g, the same thing. We could do that for looking at g. At 0, we're at -4. At -1, we're at -3. At -2, we're at -2. We could make the whole table. So if you like the table better, you could always go backwards. In fact, we'll get to a point where you can write down the functions for these, right? If you know your functions, you could also go all the way to your algebra version here. This is just a line with a slope of -1 and an intercept of -4. So we could write that function. And then we have not covered, but it's coming up next, the f of x, the absolute value functions. But this absolute value function, f of x, is equal to, it's an absolute value shifted to the left, which means I need a +2. Sometimes it takes me a second. So we have the two functions if we wanted to do this algebraically. So my point is, you should be able to go from one to the other. There are a few exceptions, right, when we're given a graph that we can't get to the original, but these are simpler graphs. So the next one, we are now doing f of g of -5. So we need to figure out what g of -5 is. -5 is way out here. Our g is at a y of 1. So we're just looking for f of 1. And at 1, it looks like our f is right here at 3. So there is our composition of functions using all three ways that we can go ahead and write or show a function.